Dear students, this is the lecture about indoor climate, one of the occupational hazards. First, let me remind you the 5 different groups of occupational hazards which we use for risk assessment. The first group is physical hazards. Inconvenient indoor climate, inconvenient lighting, other non-ionizing radiation, noise, vibration, and so on. Then the chemical hazards such as inorganic compounds, organic compounds, toxic gases, and so on. The third group is biological hazards. Bacteria, nowadays very important topic, viruses, but also protozoa, fungi, and dust. And the fourth group, psychosocial hazards, which is divided into 2 different subgroups. One which talks about work relations, and the other one which talks about working alone, monotonous work, isolation work, and other work context-based hazards. The fifth group is physiological hazards, such as compulsory postures like standing, sitting, physically heavy job, and also lifting weights and repetitive motions. It is argued that physical hazards are very easy to assess because we can measure them and therefore set objective norms for them, but also we can feel them. With our ears, we feel noise. With our eyes, we feel lighting. With our skin, we feel indoor climate. And with our hands, we feel vibration. So let's talk about indoor climate. There are several variabilities which you can assess while assessing indoor climate. When you enter to the room, then the first things what you think are air temperature and the content of oxygen in the air or air stuffiness. So why do we think about those? We think about air temperature because comfortable zone for air temperature is very narrow. Usually it's only 2 degrees, which means that, for instance, for the Nordic people, 80% of workers feel that the comfort temperature is around 20 to 22 degrees of Celsius. If the temperature gets lower in the room and you are doing office work, then your hands start to feel cold. And when it's higher, then you start to sweat. So that's why we so well feel about the temperature, which is the measure of the heat content of the air. However, it doesn't really affect our productivity much, especially when we talk about mental work. We can have up to 90% of our productivity from 15 degrees until 26, 27 degrees. Of course, it also is connected with our clothes and what are we wearing. However, the productivity of physical work is something different. It starts to decrease considerably from 26 to 27 degrees of Celsius and is almost half when it's over 35 degrees. So we have to keep in mind that people work well in temperatures between 20 to 25 degrees of Celsius, and it's important to try to have the temperature in the comfort zone. The next variable what I would like to discuss today is air pressure. It's the force exerted by the weight of a column of air above a particular location measured either in millimeter of mercury, millibar, or hectopascal. And it is measured using a barometer. But it's not a variability what we can change in our working environment. However, it can have 3 different effects on people. The first type is the increased medical complaints, which means that when the people already have some kind of diseases, those problems can become stronger. Like many arthritis victims claim that their condition worsens and cardiovascular problems may become stronger. It can also affect our emotions, especially depression-like emotions, which can become stronger. And it can increase our disruptive behavior. There have been several very interesting studies which talk about poor or low behavior in the classroom. One Japanese research has found out that low air pressure means that people tend to be more absent-minded. So you can blame low air pressure while having bad test results or bad results for the exam in your university. The third variability, what I would like to discuss, is air velocity, the rate of displacement of air measured in meter per second by anemometer. Air velocity is important because it favors the sense of air temperature, and it also promotes evaporation, and it promotes the heat exchange. But of course, air velocity can also cause drought. So therefore, it is important to keep air velocity until 0.2 meter per second and not more in the working environment. The next variability what we can measure and discuss in the working room is air humidity. First, air absolute humidity, what is the quantity of water vapor present in air. However, usually we measure and talk about air relative humidity, which is the ratio of the vapor partial pressure of the air to the saturation vapor partial pressure of the air at a prescribed temperature, and the unit is percentage. It's interesting to say that air humidity is not that important for the workers in the sense of how sensitive they are for it. So it's measured from 0 to 100%, and usually we only start to be more sensitive about humidity when it's very, very low, less than 10%, and we start to feel it's humid when it's more than 70 or 80% inside the working room. Optimum zone, considering bacteria and viruses spread, fungi, mites, allergic rhinitis and asthma cases, is 40 to 60%. Humidity also means that in high humidity, when it's a hot situation, the people feel even more hotter because the sweat will not quickly evaporate to cool us. In cold air, we will always have a lower moisture content, and so the humidity is not important in cold. And then it's the oxygen content of the air, which should be more than 90%, because if it's less, we start to feel it, and also the ability to work is disrupted. It's already very critical when the oxygen of the air becomes less than 15%, because the respiration gets steeper, the pulse rate is increased, and it causes impaired coordination. From 10 to 12%, you start to develop blue lips, performance fails, and the further pulse rate is developed. And less than that, it's already quite life-threatening. So we need to optimize indoor climate values. We need to design and plan measures, such as if we work in manufacturing, we should try to design hot departments to different names of the building. We have to keep in mind that heat flows emitted by machines should not cross, and materials which are cooling down should not be placed to the fresh air entrance. We can, of course, also try to implement constructive measures, like screens, sealing the machines. Also, we should try to lower the outside surface of machines. And if the conditions are really hard, then maybe we should find out the ways how to automate and the process, like distant piloting. But the most common way to ensure optimized values for the indoor climate is ventilation and air conditioners. And in cold environment, we of course use protective clothing. In cold environments, it's also very important to ensure workers with warm indoor climate as well, where they can go for the rest and where the hot drink is also available. Thank you for listening. Have a nice day.